Welcome to the second lecture on business process mining. In today's lecture, we are focusing on performance measurement and dashboards. The main purpose of this lecture is to give you an overview of how to think about business process performance, what are the typical measurements, and how to represent those measurements via the use of dashboards. So without further ado, how to measure process performance. As we saw last week, if you had to choose between two services, you would typically choose the one that is faster, cheaper, and better. This naturally leads us to the three dimensions of process performance: time, cost, and quality. In the upcoming slides, I will introduce you to the main performance metrics used for each of those dimensions. Let's begin with time measures. Arguably, the main time measure is the cycle time. This can be seen as the mother of all time measures in business process management and process mining. What it refers to is time between start and completion of a process instance. It consists of two components: processing time and waiting time. Those respectively refer to time taken by value-adding activities and time taken by non-value-adding activities. So for example, if you are in a warehouse waiting for a truck that you can load goods onto, then that would be waiting time. However, when you are already loading the goods to the truck, then that would be processing time, since that loading goods to the truck produces value to the customer eventually. When it comes to cycle time, obviously we want to minimize it, but within the cycle time metric itself, there is another important measure, and that is cycle time efficiency. So if we take the processing time of our process, we divide it by the cycle time of our process, then we get cycle time efficiency, which tells us the ratio of work that is actually spent on value-adding activities. For example, if our cycle time efficiency is only 10%, then this means that on average, 90% of total cycle time is spent on non-value-adding activities. Obviously, cycle time efficiency is something that we want to keep as high as possible. However, depending on the domain and the specific process, actually 10% can be sometimes even the best that you can achieve. For example, if your process involves a lot of moving of goods from one place to another, then those processes tend to have low cycle time efficiencies. Meanwhile, if we are working with, let's say, e-commerce on a local market, then those can have cycle times that are high as 90% or even more. Next dimension would be cost measures. So how do we measure process cost? Usually it is done in terms of per instance cost. So cost of a process instance. And this is usually measured from the perspective of the process owner. As with cycle time, it can be divided into two components: one, processing cost, and two, cost of waste. And those respectively refer to cost of value-adding activities and cost of non-value-adding activities. For example, when you are loading goods to the truck to be sent to the customer, then that would be under processing cost, as this finally adds value to the customer. However, when you are just reorganizing your warehouse, moving stuff around, then this does not provide any value to the customer and can be seen as a potential area of waste. Here, there are some typical components of cost. We have material cost, which is the cost of tangible or intangible resources used per process instance. So all the process inputs that you require, for example, the raw materials that you require. The second component would be resource cost, which is cost of person hours employed per process instance. So the salaries that you have to pay to the employees who are fulfilling some roles or doing some activities within your process. Now that we have mentioned already resources or resource cost, there is another important measure, which is resource utilization. So if we take the time spent per resource on process work, and we divide it by time available per resource for process work, then we get a measure of resource utilization. This is a measure that we want to keep as high as possible. However, to understand what it means, let's look at a value. So if we have resource utilization 60%, then this means that on average, resources are idle 40% of their allocated time. Now, as I said, we want to keep it as high as possible. However, there is one caveat to this. We can't push resource utilization indefinitely because it has a trade-off with waiting time. In general, when resource utilization goes above 90%, then it has been observed that waiting times increase steeply. The reason for this is that, let's say your resources are fully loaded throughout the week. Then on Monday you get an unreasonably high demand or unexpectedly high demand. What this is going to produce, or what is going to happen then, since you don't have resources available to meet this now increased demand, you are going to generate queues in your process, meaning that some orders that you get on Monday will be queued and fulfilled on Tuesday, Wednesday, Thursday, and so forth. So be a bit wary when optimizing for resource utilization. And the final dimension that I mentioned is quality. When it comes to quality, there are three aspects that we want to mainly look at. First off, product quality. This is in general measured in terms of the defect rate. So how many process instances, or what is the ratio of process instances that ends up in a negative or undesired state. And this is a rate that we want to keep as low as possible. Then we have delivery quality, usually measured in terms of on-time delivery rate, meaning that if you promise to deliver goods in 5 days, then the ratio of process instances during which this delivery requirement is actually met. And on-time delivery rate we want to keep as high as possible. Another interesting measure here is cycle time variance. This refers to the fact that we want to keep our process more or less predictable to the customer. So if our process, we deliver the goods within 3 days, then we want to deliver them in 3 days most of the time, if not all of the time. If there is high variance, we sometimes deliver it in 1 day, sometimes in 7 days. Then even if it meets our on-time delivery demands, then this variance means that the customer can't be sure when the goods are actually delivered. And finally, an indirect metric would be customer satisfaction. I say indirect because this is something that we can't influence directly. It is usually measured in terms of customer feedback scores and net promoter scores. And why I say indirect, just to give you a concrete example, you cannot go to a customer, or you shouldn't go to a customer and tell them 5 stars rating, please put it now on Amazon. It would be counterproductive to do it like that. Instead, you have to focus on product quality, delivery quality, and through that raise the customer satisfaction. Now, there are some other process performance measures that you should be aware of. First of all, how to measure demand for the process. This is usually done in terms of case arrival rate, written with the letter lambda. And this refers to number of new cases created per time unit. An alternative measure is the case inter-arrival time, which means the average time between 2 new consecutive cases. An example of measuring demand would be number of new purchase orders created per day. The second metric I want to show you is measuring the workload. So this is usually measured in terms of work in progress, which means average number of cases that are active, meaning that the cases have started but not yet completed. For example, number of purchase orders that have been received and not yet fulfilled. Now these two metrics lead us to an interesting law called Little's Law. And Little's Law relates demand, workload, and cycle time as follows. Work in progress equals arrival rate times cycle time. For example, if we receive 10 customer claims per hour and it takes us 2 hours to solve a claim, then we can use that information to figure out the number of unresolved claims in our system. In this case, it would be 10 times 2 equals 20 unresolved claims. A maybe more interesting way of using Little's Law is by rearranging it in order to determine the cycle time of the process, because in some cases, cycle time of individual process instances, and therefore the average cycle time, is a bit tricky to measure. For example, if we know that on average there are 50 customers in our restaurant, and we know that 25 customers arrive every hour, then we can calculate that the customers spend 50 divided by 25 equals 2 hours in the restaurant. Additionally, here we can see that 2 hours in the restaurant might be a bit too high. So using Little's Law, we can kind of reason a bit about what we need to change in order to drive that value down, if that would be our wish. Now that we have covered quite a lot of different process performance measures, we also have to discuss how to identify those measures or the relevant measures when you are working with a specific concrete process. The way it usually works is that, first of all, the upper management of the organization is going to define organizational objectives and KPIs. This can be done through something called balanced scorecard. It is something that we will not be discussing in this course, but if you are interested, then that would be the key word to look for. And those organizational objectives could be, for example, to improve customer loyalty in terms of returning customers by 10%. Based on that, we can define or formulate for each process the performance objectives. In this case, we could define that the objective is that the customer should be served always in a timely manner, assuming that there is a relation between loyalty and serving in timely manner. Once that is in place, we can, for each objective, identify variables and aggregation methods. This is going to give us our performance measure. In this case, our variable would be number of customers served in 30 minutes or under 30 minutes. We would use the aggregation method percentage, and this gives us the performance measure, number of customers or percentage of customers served under 30 minutes. And finally, we will define a target to meet, and for this performance measure, we could say that 99% of customers should be served under 30 minutes. Now, when it comes to those 4 steps, then the first step is something that we will not be dealing with in this course. This relies more into the strategic management or upper management of a company. Formulating process performance objectives, we will look into a bit, but not too much. In general, what we are looking towards during the rest of the course is how to provide information on how to understand those metrics and figure out if those metrics are not met, then what is the reason why they are not met, and how we can change the process in order to meet those performance measures. Now, one final thing for this part of the lecture. You don't have to think about all the performance metrics yourself. It is an area where there has been quite a lot of research already, and there are some reference models that you can rely upon. For example, Supply Chain Operations Reference Model, or American Productivity and Quality Council, or IT Infrastructure Library. There are, of course, others, but this is just to give you an overview that those frameworks, they already exist, and based on your specific domain in which you are working, it is always worth looking at if such a performance framework is already there and what are the relevant parts for your process.